So yes, this is the next question. A block weighing 15 Newton rests on a flat surface and a horizontal force of 3 Newton is exerted on it. Yes, this question is actually very technical. Yes, most of you would have. Yes, let's just write it down. They said the block is weighing 5 Newton. So the weight of the block is what? 15 Newton, I mean. So your R is also what? 15 Newton. R is the same thing as W. But you actually don't need it. You see it now. Yes, they said an horizontal force of 3 Newton. This is the force, 3 Newton. Then they said what will be your frictional force? It's actually very simple. What's the formula? Net force is equals to what? F minus what? Frictional force. So what's the net force? You know it's 0, right? Because it's not moving. What's your frictional force? 3 minus Fr. So Fr is what? 3 Newton. You may be surprised. Oh, why don't you use 15 Newton? It's not there to confuse you. You only need your 15 Newton if you don't have your Fr before. Like let's say you don't have your Fr, you need to get your Fr. You can now say mu R. Yes, this is, but now you've been given Fr, so you actually don't need your R again. So Fr, frictional force is what? 3 Newton. Please be careful of this type of questions. Yes, let's go. Yes. Now, yes, let me just say this in addition to that before we move on. So I said frictional force is what? This is the, we should have used, we may be bothered that why don't we use R? Yes, you know, we are looking for our frictional force. We should have used this formula, mu R. Yes, but our R is 15. We don't know our mu. We don't know our mu. So this formula cannot work. That's why our R is useless, because we don't know our mu. So you just go by the normal method. Net force is equals to what? F minus frictional force. Net force is 0. Your force is 3. Then minus frictional force. Frictional force is 3 Newton. Yes, let's move on now. Now, before we take the next one, let me just let's go to the next step. Now, when they said the body is sliding or the body is now moving, yes, the only thing that you need to ask is that, you know, your net force is always F minus what? Minus frictional force. So in this case, it will no longer be, it will be MA. So you just put your acceleration here. It will no longer be 0 when the body is moving. So you just put your acceleration here. You can be asked to find it. Don't worry, we'll take questions on that now. So there's just that. Then you can be asked to find the speed. This is the formula you use. Mu is equals to u square over 2gs. Please take this formula very importantly. Mu is equals to u square over 2gs. Mu is equals to u square over 2gs. Yes, so that's all. Let's take another question now. So yes, this is the next question now. A force 10 Newton. Let's yes. Drags. Can you see drags? So the body is now moving now. This is the mass, 10 kilogram. So what will be your weight? Weight is what? 10 times. You know, weight is mg. So 10 times 10. That's what? I'm sorry. Yes, so weight is what? 10 times 10. That's what? 100 Newton. Yes. So let's move on now. Let's move on now. So they said a force 10 Newton drags a mass. So this is the force. Is dragging the mass. Is dragging the mass. Is dragging the mass. Yes. Let's say they said if the acceleration due to gravity is, you know that already. Okay, with an acceleration of 0.2 meter per second square. So the acceleration is what? 0.2 meter per second square. 0.2 meter per second square. Then they said if the acceleration due to gravity is 10 meter per second square, the coefficient of friction is what? Yes, we've already used our G. This is it. G is 10. Yes, they said what's the coefficient of friction? So write your formula. Net force is what? Your friction will be here. Your frictional force will be here. Your frictional force will be here. So net force is equals to F minus frictional force. What's your net force? MA is equals to what's F? F is what? Our F is 100. No, let's check the question. Yes, this is it. A force of 10 Newton. So our F is 10 Newton. So F10 minus what's frictional force? Frictional force is what? Mu R. What's mu? Mu times. What's R? You know that our R is the same thing as what? Our weight. Our R is mg. So that's what? 100. So we have our mass. What's our mass? Our mass is 10 kilogram. Times what's our acceleration? 0.2 is equals to 10 minus 100 mu. So 10 times 0.2, that's what? 2 is equals to 10 minus 100 mu. So collect the like times. 100 mu is equals to 10 minus 2. 100 mu is equals to 8. Mu is equals to 8 over 100. Mu is equals to 0.08. So the only difference is that your A will no longer be 0. So the value of your A that you're given, just slot it in. So that will get you your answer. Yes. Let's take another question now. So this is the next question. When a box of mass, all these questions are actually jam-packed questions. So immediately after you finish watching this video, just go to your remix or your past questions. Try to solve every form of question there. Yes, when a box of mass 45 kilogram is given an initial speed. So they've given you the speed, initial speed. That's what u. U is 5 meter. There's actually a difference between u and mu. Do you understand? This mu is the coefficient of static friction. This u is the what? Is the initial speed. Yes, let's move on. Of 5 meter per second, it lies along a horizontal floor, a distance of what? 3 meter. So the distance is what? 3 meter. I gave you a formula relating this. What's the coefficient of kinetic friction? Coefficient. So I told you that to get this, when you are to get the speed, you use what? Mu is equals to u square over 2gs, right? So what's your mu? Mu is equals to, what is your u square? 5 square over 2 times 10 times 3. 5 square is what? 25 over 2 times 10, 20 times 3. This is what? 25 over 20 times 3 is what? 60. This is what? 5 in 25, 5. 5 in 60, 12. So mu is what? 5 over 12. Do you get it now? Yes. So that's just that. Let's go to the next case now. Now, if you remember at the beginning of this video, I said something that there's a common formula that is used. Mu is equals to what? Tan theta, right? Yes, and I said this is only effective if the body is what? Sliding. The body is sliding. If the body is in motion. If the body is in motion. Yes, so this formula is very vital. Let's just review all the formulas together now. We said friction is what? Mu r. That's the first formula. Then we said net force is what? Net force is F minus what? Frictional force. Then we said R is always W. Do you remember that? Now, this is for the normal ones. Then when we get to a body that is moving, when the body starts sliding, we said MA is equals to what? F minus FR. Then we also said mu is equals to U square over 2gs. Then we said mu is what? Tan theta. So I think we've not done anything more than this. So let's just take one last question before we move on. Yeah, so this is the question now. A body of mass 10 kilogram rests on a rough inclined plane whose angle of tilt theta is variable. Theta is gradually increased until the body starts to slide on the plane at 30 degrees. Yes, this is actually what they are saying. There's an inclined plane, but you don't need to stress yourself. They're giving you the theta and you know it's sliding. Yes, the coefficient of limiting friction. So that's what we use it for inclined plane. We use this formula for inclined plane. Mu is equals to what? Tan theta. So we will launch into inclined plane fully shortly. So mu is what? Tan. What's your theta? That's what? 30. So mu is what? Tan 30 is what? 1 over root 3. If you press it in the calculator, to give you what? 0.5771 or 0.58. Yes, so that's just that. That's just that. Let's go into inclined planes now. But before then, let's take a special case. Yes, let me explain that now. Although this type of question is not common, but they can ask. So I want to touch every part of friction so that nothing about friction is giving you problem again. Yes, let me just take it now. Yes, let me just give an illustration. Let's say that we have a body of mass 55 kilogram. Yes, you already know that your weight will be what? Your weight will be 50 Newton. How do we get it? Weight is mg. And you already know that it is the same thing as your what? Your reaction. Reaction is the same thing as weight. Yes, so let's try to solve this now. Now, okay, I said they can give you a case whereby they will tell you that a rope is used to pull this thing, not a normal force. The force is not like this. The force is in the form of a rope. Yes, there's a tension in that rope. Then the rope is at an angle to the horizontal. Yes, so they can give you a type of question like this. Now, if they give you a question like this, you will know that R will no longer be equals to what? W again, because the vertical forces that we have is actually now more than R and what? And W. We have another force here, because if I am to trace it like this, let's get this force. Let's call this one our what? Our Fy. Let's call this one our what? Fx. Let's just call it. Yes, what will be my Fy? Let's call this one my tension, or let me call it F. So what will be my Fy? Fy is equals to what? F sin theta. How do I get it? Sin theta is equals to opposite over hypotenuse. Yes, sin theta is equals to opposite over hypotenuse. What's my opposite? This side. This is my opposite, Fy. Over what's my hypotenuse? F. So let's cross multiply. Fy is equals to what? F sin theta. If you use the same approach, you find your cos theta. Fx will be equals to what? Fx is equals to F cos theta. F cos theta. Please make sure you master that. So if I want to write my total force now for vertical, please take notes. This is where, so that you don't, in case they ask, yes, it's actually complex, but they can ask. Yes, let's take for the vertical component. We have three things. We have R, right? Then we have Fy. Fy is also acting upwards. This Fy. Then we also have what? We also have W. W is acting downwards. So if I'm to balance it, what's up? R plus what? Fy. Right? Is equals to what? Is equals to W. So this is for my what? My vertical. So it's no longer R is equals to W. So if you have this type of question and you see R is equals to W, you will be wrong. Because R is actually not equals to W. It is R plus, what's the other force? Fy, that is equals to what? W. Do you get it now? Yes, now they can ask that, how do you know when you will use this? Yes, anytime they tell you that a rope is used to drag something, or a rope is used to, yes, that's when you, yes. Now for the horizontal forces now, in fact, there can be other questions where they will still say a force is pulling it in this direction. If you have a force pulling it in this direction, you know that this is your frictional force, right? So your net force will be what? What's the one acting here? You have your normal force, then your F cos theta, which is your Fx, then minus what? Minus your frictional force. So this is your what? This is your net force. And don't forget that your Fy is what? F sin theta, and your Fx is what? F cos theta. So that's just all you need to know. Let's just take a question on it. It's actually not common, but you just take 1 or 2 questions on it and we'll be fine with it. Yes, so we have the next a question on that now. A concrete block of mass 35 kilogram is pulled along the horizontal floor. This is it. Mass 35 kilogram. So what will be your weight? Your weight will be what? Mg. So your weight will be what? 35 times 10. Your weight will be what? 350 Newton. So let's read on. It's put along a horizontal floor with the aid of a rope. Can you see it now? So we are using a rope to pull it. Inclined at an angle of 30 degrees to the horizontal. 30 degrees to the horizontal. Can you see it now? So what will be your, so you already know that you will have a vertical force like this, Fy. Then we have an horizontal force like this, Fx. Do you get it now? Then your normal reaction will be R. Do you get it now? So if I'm to write it, they've given us the coefficient of friction. Is what? 0.75. They said, what? Calculate the force required to move the block over the floor. So they said they should calculate the force required to move the block over the floor. Yes. So you already know that your Fy is what? F sin theta. And your Fx is what? F cos theta. So you are asked to find this F. No force is pushing it again. This is just what you have. So let's just try to write the balanced equation. Yes. Okay, for the vertical, we have what? R plus what? Plus Fy. Are you following? Is equals to W. So I can say R plus, what's my Fy? F sin theta. What's my theta? F sin 30 is equals to, what's W? 350. So my R is what? 350 minus F sin 30, equation 1. Now, so we have, don't be scared by maybe equation 1 or anything. It's very simple. It's very, very simple. So let's take the next part now. Let's take for our horizontal component. Our horizontal component is what? Net force is equals to, we actually do not have any other force here. So the only force that we have here is what? Fx. So it will be Fx minus what? Your frictional force. You know, this is your frictional force. Fx minus frictional force. So yes, what's your net force? Now, this body is not moving yet. Let's just read through the question. The body is not yet moving. So your net force is what? Is 0. M times 0 is equals to, what's your Fx? F cos theta minus, what's Fr? Mu R. Right? So you have M times 0, that's 0. What's F? That's what you are looking for. F cos 30 minus, what's your mu? Mu is what? 0.75 times R. What's your R? That's what you got in our equation 1. 350 minus f sine 30. It's actually not complex. Yes, this is where friction can get, but it's actually not. Just follow through the procedure. Immediately after this video, if you don't get it, just play back a bit. Just play back a bit and make sure you get it well, because you can say they may not ask, and this will be the particular one that they may ask. It's not common, but they can ask. Don't let me say they will ask. Let's move on now. So let's move on now. 0 is equals to, what's cos 30? F. Now you may be wondering, how is 350 minus f sine 30? That's what I just slot in. Where I have my r, I just put it 350 minus f sine 30. So we have, what's cos 30? Cos 30 is actually what? 0.866, right? Minus 0.75 times 350. That's what? 0.75 times 350. That's 262.5. 262.5. Minus 0.75 times minus f sine 30. That will be what? That will be plus. Yes, let's multiply. So we have 0.75 times sine 30. So that gives us, I'm trying to press it here. 0.75 times sine 30. So that gives me 0.375. 0.375 f. So that's just that. So let's solve on 0.866 f minus 262.5 plus 0.375 f. So collect the like times. Bring this minus 262.5, bring it here. So that will give you what? 262.5 is equals to 0.866 f plus 0.375 f. So yes, add these two together. 262.5 is equals to, so we have 0.866 plus 0.375. That's what? 1.241 f. So you divide both sides by 1.241. 1.241. So f will give you what? Let me press it here. 262.5 divided by 1.241. That's what? 211.52 Newton. Do you get it now? So that's just it. Please make sure you follow through. It's actually not hard. Just go through it again. We have just, okay, let me do something for you now. I will help you solve it again. So just follow through so that it won't be complex. Now let me just help you solve it again. Let me just use another fresh sheet now so you can follow using this. Yes, let's go now. They said a concrete block of mass 35 kilogram. This is it. A concrete block, mass, please follow again now, mass 35 kilogram. So this is your weight. Weight is what? 350 Newton. How do we get it? Mg. What's m? 35 times 10. That's what. So you have another force here, which is your reaction. They now said they are pulling it with a rope. A rope. And the rope is at angle 30 degrees to the horizontal. So what will be your new vertical force? This place is what? So you have a new vertical force. This place is the same thing as what I draw here. So you have a new vertical force. That new vertical force is what? Is the same thing as what? Fy. Fy. Then this down part is what? Is your Fx. Fx. So the force that we have like this is what? Fx. So just take it one after the other. Start with your vertical force. Vertical forces. Yes, what are your vertical forces? You have 3 vertical force, R, Fy, and what? W. Add the upper one together, equate it to the lower one. R plus Fy is equals to the lower one. That's what? W. That's how I got this equation. So what's my R? R plus, what's Fy? Fy is what? F sine theta is equals to, so we have, what's our W? 350. So my R is what? 350 minus F sine theta, right? So that's my R. That's my R. 350 minus F sine theta. So that's the vertical force. Don't let me call it equation 1 so as not to scare you. So let me do for my horizontal forces now. Yes. So we have how many horizontal forces? We have Fx. Then you know that your frictional force will be acting antagonistically. So we have 2 frictional force. So your net force is what? Fx minus what? Minus Fr. Do you get it now? And you know that your net force is what? Is 0. So what's my Fx? F sine F cos theta. We proved that already. Minus what's Fr? Mu r. So you have what? 0 is equals to F cos theta minus mu r. Let me make it easy. Just bring this minus mu r to this other side. So you have what? Mu r. When mu r comes here, it will become what? Mu r is equals to F cos theta. Do you get it now? So F cos theta is equals to what? Mu R. F cos theta is equals to, what's our mu? They've given us our mu from the question. Yes, they said if the coefficient of friction is 0.75, so coefficient, this is 0.75. What's our R? We've gotten it here, 350 minus F sine theta. Do you get it now? So what's F cos theta? You just, what's our theta? Our theta is what? Inclined at angle 30 degrees. So F cos 30 is equals to 0.75 into bracket 350 minus F sine 30. Let's solve it on F. What's cos 30? 0.866. So you have F times 0.866. That's what? 0.866 F is equals to 0.75 times 350. That gives us what? That gives us, I'm trying to remember what we got the other time, but let me just press it. 0.75 times 350. That's what? 262.5. 262.5 minus 0.75 times, what's sine 30? 0.5 times this one. That will give us what? 0.375 F. Yes, so it's just the same thing we did the other time. So 0.866 F, bring this one to this place, plus 0.375 F is equals to 262.5. So this is what? 1.2. I'm trying to remember. Let me just add it so that we are accurate. 0.375. That's what? 1.241 F is equals to 262.5. So you divide both sides by what? 1.241. 1.241. So your F is what? 262.5 divided by your answer. That's what? 211.52 Newton. So that's just that. If you still don't get it, please just try it again, play back, and I will give one more example on this so that you can grab it well. Now, the next question, a horizontal force of 45 Newton. Let's do this now. Now, this one is very close to that one, but it's somehow different. It's applied to a crate of mass 9 kg. It's just sufficient to move it. Yes, let's do this now. They said apply to a crate of mass 9 kg. This is it, 9 kg. So what will be your weight? Weight is what? Mg. Weight is 9 times 10. Weight is 90, right? They said apply to a crate. So this is an horizontal force, 45 Newton. They now say if the crate is now pulled at an angle of 50 degrees to the horizontal, if this 45 Newton, if we change it, if we now pull it at 45 degrees to the horizontal, that means if you have it like this to the horizontal 50 degree, so our F is now what? Our F is now 45. Do you understand now? Yes, they now said find the force required to move the crate over the horizontal surface. So they said you should find the force that is required to move the crate over. This is very simple actually. Yes, the force required to move the crate over the horizontal surface. Okay, yes, let's just check this question well. Now, the reason why they gave you in two cases is that, let me explain again. They said the horizontal force of 45 Newton, this is the force, is applied to a crate of mass 9 kg, and it's just sufficient to move it. So from here you can get your frictional force. You know, we have the net force to be, so yes, we have our W to be 90 Newton. So they want you to get your coefficient of friction. That's why they gave you this value. You know that your net force is equals to what? This force minus what? Minus frictional force. Yes. What's the net force? 0, right? What's the force? 45 minus frictional force is mu R. What's our R? Our R is the same thing as 90. Now, the reason why we can still say R is the same thing as 90 is that we've not said we are pulling it at any angle. We've not come to the second case. We are still on this first line, a horizontal force. This is the line I'm still dealing with. Yes, it's just sufficient to move it. This is the line I'm still dealing with. Yes, because it's actually two cases. Don't worry, this type of questions aren't common, but I just need to explain so that there won't be any type of question you won't be able to solve. Let's move on now. So we have 0 is equals to 45 minus 90 mil. So we have 0 is equals to 45 minus 90 mil. So we have 90 mil is equals to 45. So you can divide both sides by 90. So your mu is what? 0.5. Do you get it now? So yes, let's move on now. They now said if the crate is now pulled at an angle, let me just draw it this way. Oh, just pardon, let me just cancel this and just try to draw it again. They said if the crate is now pulled at an angle of 50 degrees to the horizontal, now they are using another force now. They did not tell you that first. That's why I have to cancel that. If the crate is now pulled at an angle of 50 degrees to the horizontal, 50 degree to the horizontal. Yes, they said find the force. So you are getting this force. So required to move the crate over the horizontal surface. So let's solve it now. You have your normal reaction here, right? You have the weight acting down. The mass is the same. Mass is constant. So your weight will be mg. Your weight will be mg. So weight is what? 9 times 10. Weight is still what? 90 newton. Do you understand? And you know, since we are now pulling it at an angle, we are pulling it at an angle of 50 degree. So your Fy will be what? Your Fy, this is your Fy, and this is your what? Fx. So let's, using the method I explained the other time, vertical. So what's our vertical force now? Our vertical will be what? R plus Fy is equals to what? W. I hope you are getting it. So what's your R? R plus, what's your Fy? Fy is what? F sin 30. F sin 30 is equals to 90. So R is equals to 90 minus F sin 30. Oh, please, I made a mistake. Like this place should be 50 degrees. So this is F sin 50. Sorry. F sin 50. F sin 50. Exactly. Yes. Let me just move on to the next page now. So let's check for the horizontal forces. Horizontal forces. Horizontal forces. So yes, let's relate the diagram again. You know, you have your net force. Your net force is what? Is Fx minus what? Minus your frictional force. If you remember the diagram. So what's your net force now? Is 0. It's not moving yet. Then what's your Fx? Fx is what? F cos theta minus what's frictional force? Mu r. So 0 is equals to what's cos theta? F cos 50 minus what's mu? We've gotten it already, 0.5. You remember how we got it? Yes, times r. What's r? 90. So 0 is equals to F cos 50 minus 45. Oh no, our r is, I'm sorry, our r should be 90 minus F sin 30. 90 minus F sin 30. Sin 50, I mean. So this will be what? 0.5 times 90, that's 45. 0.5 times minus, that will be what? Plus 0.5 times F sin 50. Now this is another reason why JAMB will not ask this one. Why can ask, but JAMB, because there's no sin 50 in your calculator. So if they will ask, they will give you a better angle, maybe sin 30 or sin 45 or anything like that. So yes, let's try to press it now. 0.5 times sin 50, that will give you what? That's what? 0.383. So this is 0.383 F. Yes, let's move on now. F cos 50. F cos 50. That's what? 0.643 minus 45 plus 0.383 F. Let's just add it up. So we'll have minus 45. This minus 45 will come here. So we have 45 is equals to 0.643 F plus 0.383 F. So let's add it up. 45 is equals to what? That's 1.026 F. Divide both sides, 1.026. Yes, F is what? 43.86 Newton. So that's just that. You can just play back and try to watch it over again. Yes, let's treat inclined planes now. Inclined planes. But before we treat inclined planes, let me just quickly make a recap of the last part we did. It's actually not hard. This is it. They said a body then is pulled. This is your F. Then this is your F sin theta. This is your F cos theta. It's as simple as that. Then you know that this is your normal reaction normally. Then this is your weight. So you just get your, this is your frictional force. Just balance it up. Your vertical forces. What's your vertical? Your vertical is what? R plus what? Plus F sin theta, which is your Fy. F sin theta is equals to what? Your W. Then your horizontal is what? net force is equals to what? Fx. Your Fx is F cos theta minus what? Minus Fr. So it's as simple as this. This is the only thing you need to know. Yes, let me go to inclined planes now. Inclined planes. Inclined planes. Yes, if a body is inclined, let's draw something like this. So this is an inclined plane. This is an inclined plane. So let's say it's at an angle, maybe theta. So yes, let me just explain. You know, this angle, yes, like this is the weight of the body. This is the weight of the body. Then you have your, this is your normal reaction. Can you see? Like your normal reaction is like this. It's perpendicular to this. No, it's just, this is just like the continuation of this. Then this is your weight. This is your weight. Just call it W. Just call it W. Then this one, this angle is equals to this angle. What's the reason? They are alternate angles. Don't mind the proving. You don't need to know the proving anyway. But you can just follow on. This, they are alternate angles. So this theta is the same thing as this theta. So yes, let me get this place. If I'm to get this place, if I'm to get this place. So this is opposite. This is my what? This is my hypotenuse. So I can say this place, if I get this place very well, this would be my what? W sin theta. Yes, how do I get it? Sin theta is equals to what? Opposite. This is my opposite. Let me call it maybe x is equals to what? Hypotenuse W. Cross multiply x is what? W sin theta. That's how I got this W sin theta. Yes, then if I want to get this place will be what? W cos theta. W cos theta. You can also solve it. Cos theta is equals to adjacent over hypotenuse. So it's just the same thing. So now I can say this place is parallel to this place. W sin theta. This place is what? Is parallel to this place. W sin theta. Please don't be confused. It's just normal proving. This place is parallel to this place. This is like this, parallel to this place. Do you understand? They are parallel. It's just the proving. Don't worry. Yes. Then we also have something like this. Let's say if force is used to push this one up. Let's just say if force. I'm just trying to give all the types of cases you can have. Yes, let's move on now. So we have W sin theta. W sin theta is here. Please don't be confused. Don't be confused. So let me just, if you have to get your net force, let me start with the horizontal in this case. Horizontal. And I hope you remember that in an inclined plane, me is what? Tan theta. Don't forget. Me is tan theta. Me is equals to tan theta. Me is equals to tan theta. So yes, horizontal resolution, the resolution of the horizontal forces. So we have net force is equals to F minus W sin theta. Then minus what? Minus your frictional force. Minus your frictional force. Don't be confused. Yes, this is it. You have your F here, right? Then this is your W sin theta. And you know that if you know that if your F is here, your friction will be what? Your frictional force will be here. So it's just the same thing. So your net force is what? F minus W sin theta minus frictional force. Yes, let's check for the vertical forces. Your vertical forces. So vertical forces. Yes, you have R and you have what? W cos theta. Now there is no rope. There is no rope. So your R is equals to what? R is W cos theta. I hope you get it now. So R is equals to W cos theta. For horizontal force, net force is what? F minus W sin theta minus Fr. Please don't get it confused. It is not hard at all. So let's take a question on it now. And please don't make the mistake of not going over this topic again. Make sure you practice all the questions personally on your own. Consult your remix and so that you can be fine perfectly. Yes, next question. An object of mass 15 kilogram is at the point of sliding down a plane inclined at 36 degrees to the horizontal. So this is just it. Mass 15 kilogram. So yes, this is your weight. 15. Then this is your R. Then you know that this is your what? This place is your what? Mg cos theta. W cos theta. If you remember what we drew here. I'm sorry. Let me just try to get the diagram. Yeah. So this is it. W cos theta. This place is your W sin theta. So I'm just trying to bring it to your remembrance. Yes. So this is it. we have this place is W cos theta, then this place is actually your W, then this place will be what? W sin theta, right? This place is W sin theta. Then they said find the force parallel to the plane required to move the object, to begin to move the object up. So you need a force here. You want to move it up. So if the force is going like this, where will your friction be? Your friction will be in this direction. So let's solve it now. R is equals to what? W cos theta, right? That's your vertical forces. R vertical force R W cos theta. So yes, what's R? R is equals to what's W? 15 times 10. W is what? Mg. Cos 15 times 10 times cos. What's theta? Your theta is what? At 36 degree. 36 degrees. This is your 36 degrees. Yes, times cos 36. So that will give you your what? Your R. So 15 times 10 times cos 36. That will give you what? 150 cos 36. Let me try to press it here. So this is what? 121.4 Newton. 121.4 Newton. Yes, so that's your R, but you are looking for this force. You are looking for this force. So using the formula is what? Net force is equals to F minus W sin theta minus frictional force. So what's your net force? That's 0, right? F minus W sin theta, that's 15 times 10. W is mg times sine. What's the angle? 36 minus frictional force, that's what? Mu r. So we have 0 is equal F minus, yes, this one is what? 150 sine 36. Now you may be wondering, we aren't giving our mu, but you can get it. Mu is what? Tan theta. Mu is tan theta. So mu is what? Tan 36 times, what's our R? 121.4. Please don't take it to be complex. If you are finding it complex at any point, just go back to the video, just play back and watch it again. 0 is equals to F minus, yes, 150 sin 36. That's what? 88.16, 88.17. Yes, minus 10, 36 times 121.4 times 121.4, 88.2. So this is 88.2. So your 0 is equals to F minus the addition of 88.17 minus 88.2. 84. So yes, this will give us what? 176.37. So just bring it here. F is equals to what? 176.37 or 176.4 Newton. Yes. So that's the force required to move it up the plane. Please, if you are getting it confusing, just play back and try to watch it again. Let's take the next question now. Trying to solve all the questions that has ever been asked on this topic, so that no question will seem like a burden. No question, you won't find any question hard. Next question now. Yes, can you please? You can just try this out. You can just try it out, just for some few minutes. Yes, I'm sure you've done that now. Let's take it together. So we have a concrete block of mass 25 kilogram is placed on the wooden plank inclined at an angle of 32 degrees to the horizontal. So this is it. Mass 25 kilogram. So this is your weight. Weight is what? Mg. That's what? 250 Newton. And you know that you have something like this. This is your what? W cos theta, which is equals to your what? R. So at this point you have your what? W sin theta. Then at this point you have your what? You have your force. Then at this point you have your what? Theta. What's our theta? 32 degrees. 32 degrees. So they said a concrete block of mass 25 kilogram is placed on. Yes, they said calculate the force that will keep the block at rest. So they've given you the coefficient of friction, 0.45. Yes, since it is at rest, you can't say mu is equal to tan theta. It must be moving. It must be moving for you to say mu is tan theta. So they've even given you your mu before. So let's move on now. So yes, let's take it on now. So you know already that your R is what? W cos theta. R is what? What's W? W is what? 25 times 10 times cos theta. What's our theta? 32. So R is 250 cos 32. R is what? What's 250 cos 32? I'm coming, I'm just trying to press. So that's what? 2212. 212 Newton. So that's my R. So yes, the horizontal force, net force is equals to F minus W sin theta minus what? Minus the frictional force. Yes, you know the frictional force will be like this. Yes. So let's move on. The net force is 0. What's our F? Minus W sin theta. That's what? 25 times 10 times sine. What's theta? 32. Minus frictional force is what? Mu R. Mu times. Our mu is 0.5. Let me just put it here. Mu R. So we have 0 is equals to F minus 250 times 32. So this is what? 132.48 minus, so we have mu to be what? 0.45 times, what's our R? We've gotten it already, 212. So we have 0 is equals to F minus 132.48 minus, so you have 0.45 times 212. So that's what? 95.4. 0 is equals to F minus, so let's just, so we have what? 227.88. So F is what? 227.9 Newton. Yes.